Hello and welcome. This video will show you how to get started defining, generating, and using synthetic data on the Rendered.ai platform. Let's dive in. Upon logging in, click on your organization to see your workspaces and resources, invite members, and update organization settings. To access a range of pre-built demo workspaces, check out the sample gallery. Here you'll find content designed for specific computer vision use cases you can deploy into your organization with the click of a button. Just click Create Workspace, select your organization, and click Create. Workspaces are where you and your team can define and generate synthetic data for specific computer vision projects. They leverage deployed channels, containerized applications based on the Rendered.ai framework containing the assets and code necessary to create synthetic data specific to meet the needs of your use case. Within the workspace, we can see an overview of our recent activity and create new datasets using graphs. Graphs direct the flow of operations within a channel to create synthetic data. Graphs can be configured by editing an existing graph or creating a new one. Let's create a new graph by clicking on the plus icon. Select the channel that you're working with, give your graph a name, and click Create. Now we can see the default graph that is initially configured in this channel. The nodes represent the objects, modifiers, and environments that define the graph, and the links between them show the flow of operations in the rendering pipeline. In this case, we have two 3D models, a tank and an army truck, being placed within various parking area scenes. To update this graph, let's first delete these objects. Then, to add new nodes, we can click the plus button here to open the node library. This opens a list of all the nodes defined for this channel, such as objects of interest, backgrounds, renderers, and modifiers. Let's add a new object of interest to the graph. Let's go with a tractor. Now that the object is added to the graph, let's connect it to our object placement node. We can hook up our generator output to the generator input on our placement node. This placement node defines where in the scene the object can potentially be placed and how many of them to place. Additionally, new 3D models can be added to the platform and used within graphs with just a few mouse clicks. If we go to the Assets tab, we see the volumes included in this workspace. Clicking into a volume shows the option to upload a file to the volume. I have a spaceship model that I found, so I'm going to use that. Now we can go back to our graph, open up the node library, and go to the Volumes tab. And now we'll see the spaceship model that we uploaded and can add it directly to the graph just like any other model we added. Let's plug it into this pattern modifier. The pattern modifier will apply a random pattern to the object to create diversity within the object class. If we also connect this object directly to the placement node, we will get both modified and unmodified objects in our output images. With these updates in place, we can now click Preview to see a single output image. Once you're happy with the graph configuration and preview, you can click the Stage button to stage your graph for production. This graph can now be used for synthetic data generation jobs, and it will appear in the Jobs pane. Here you can provide a name and description for your job and specify the number of images to generate. Once you hit Run, the job is added to the Jobs window, and progress can be monitored using the provided real-time indicators. When the job is complete, we can view it in the Datasets tab. Here, we can get a preview of images in the dataset alongside various annotations, including bounding boxes and instance masks. To convert annotations to match your own annotation schema, click the plus sign by the Annotations tab. This enables the conversion to a variety of industry standard formats according to custom annotation mapping files that group objects based on designated taxonomies. To retrieve the full dataset and use in your modeling workflows, click the Download button. Along with generating datasets, the Rendered.ai platform also supports the upload of real datasets for comparison purposes. Here we have a real dataset containing satellite images of construction areas. And a synthetic dataset containing tower cranes and shipping containers. To help close the domain gap between these two datasets, we've deployed a CycleGAN style transfer model trained to convert images from this synthetic domain to the domain of the real dataset. GAN models can then be run as a post-processing step, which we've done here. As you can see, this is the same synthetic dataset, but with the GAN applied for style transfer. To compare these datasets, we can select all three of them and click the Compare button. Choose a fit dataset. In this case, we want the real dataset, and then provide a name. So, construction area map, and then click the Compare button. This tool runs selected datasets through a pre-trained neural network to extract detected feature vectors. Then, using the UMAP dimension reduction technique, reduces those vectors to 3 dimensions to allow these values to be plotted visually. With the comparison complete, we can now analyze patterns in the datasets in feature embedding space. The blue dots correspond to the real dataset, the orange to the synthetic dataset, and the green to the domain-adapted synthetic. Right away, we can see that the GAN shifted the synthetic images closer to the domain of the real dataset. But we can also inspect the outliers in the real dataset to better understand what is not being captured by the synthetic dataset and whether those elements are important to our analysis. This comparison tool provides a human-in-the-loop analysis to compare and validate synthetic data.